Welcome to our presentation about the Coriolis effect. This is by
Sarai,
Shanell,
Owen,
and Gabe.
The Coriolis effect is the curving path of Earth's objects for otherwise straight paths due to Earth's rotation.
This happens because the Coriolis effect is caused by Earth's rotation.
The Coriolis effect also happens when there's an obstacle. Shanell Fuentes wrote a book about Coriolis effect, and it tells about how and where the winds travel and what caused it.
Gustav Gusbert stole the story, published it as his own, and took full credit.
Giovanni Battista Riccoli described the effect in connecting with artilleries in 1651.
Giovanni's assistant, Francesco Maria Grimaldi, helped him figure out how the effect works.
Simon Pierre found out how the Coriolis effect happens, when it happens, and why it happens. He figured out that the Coriolis effect appears in most hurricanes, which makes them move.
It happens frequently because the result of weather patterns and ocean currents.
There is also a man, Claudius Francisco Millet, who described the rotation, temperatures, and deflation on the Coriolis effect.
The Coriolis effect describes the rotation of Earth on its axis.
This was all described in 1835. The rotation is also the movement on Earth that causes winds to move right and left, and these winds are easterlies, westerlies, and trade winds.
These make storms swirl clockwise in the southern hemisphere and counterclockwise in the northern hemisphere.
The effect becomes generally more noticeable over a long distance of time.
The period of time is longest in waters and oceans.
This happens because of the global winds.
The curve happens at the equator because it's the part that is strongest.
The force explains the path of objects on rotation bodies.
The force is stronger when the obstacles are harder and because the wind blows stronger.
When an obstacle is too strong, the winds move in a left to right rotation or direction, or also a parallel to Earth in the horizon. This behavior is called Coriolis acceleration, a formula that implies it's perpendicular both directions of the velocity of moving mass.
When an object moves along a north to south path, longitudinal line deflection sways left to right.
That's when the westerlies winds are strongest.
Then when the obstacles are easy, that's when the easterlies are strongest.
Then later at the equator, when things are calmer, that's when the trade winds are strong.
In conclusion, the Coriolis effect is caused by Earth's rotation on weather patterns and ocean currents. Thank you all for watching this presentation.